Welcome to today's explainer. All right, I want you to picture this. Imagine a little wood frog settling down under a cozy blanket of fallen leaves right in the dead of a freezing Alaskan winter. It looks like a perfectly peaceful, quiet moment in nature, right? But what's actually about to happen inside this tiny amphibian? Well, it completely defies literally everything we intuitively understand about biology. Today, we're unpacking some absolutely mind-blowing source material that looks at the most baffling biological anomalies on Earth. And we're going to explore them through a really fascinating lens, the concept of intelligent engineering and complex biological design.
So, as that brutal winter sets in, the outside temperature just plummets, and the frog's body temperature drops right along with it, all the way down to a bone-chilling -6 degrees Celsius. At this point, an astonishing 65 to 70% of the water inside the frog's body freezes, completely solid. It literally turns into a living frogsicle.
Honestly, if you were to examine this frog right now, you'd swear it was dead. Its heart completely stops beating. Brain activity totally ceases. Breathing halts entirely. And we aren't just talking about a brief pause here. The frog stays in this completely powered-down, frozen state for months at a time. Yet, incredibly, when spring finally rolls around and the ice thaws, within just a few hours, the frog's heart just starts pumping again. It takes a breath and it hops away like absolutely nothing happened. No way, right?
To really grasp just how wild this is, let's put it into perspective with our own human biological limits. If a human heart stops, the brain has, maybe 4 to 6 minutes before irreversible damage and death kick in? That's our absolute ceiling. But the wood frog, it survives for months without a single heartbeat, zero breathing, zero brain activity. And it doesn't just barely survive, it wakes up perfectly healthy. This presents a massive biological mystery for us to unpack. How on earth is this physically possible?
Section 1. The engineering problem, surviving the freeze.
Okay, let's dive right into this. If we treat this frog's survival not just as some random quirk of nature, but as a highly complex engineering problem, we have to ask, why don't its cells just burst when the water inside them turns into jagged ice crystals? Well, researchers have uncovered this flawless, highly automated response. The exact millisecond ice begins to form on the frog's skin, a sensor trips. Instantly, the frog's liver activates, acting like a perfect hyper-responsive automated defense system, and it immediately starts converting its stored glycogen into glucose.
And the scale of this response, it's simply staggering. The frog's blood sugar doesn't just go up a little bit, it skyrockets to 100 times the normal level. 100 times! This massive flood of glucose basically acts like a biological antifreeze. It turns the fluids inside the frog's cells into this thick, protective syrup, which completely stops the cells from freezing and bursting from the inside out.
Now, this entirely flips our understanding of biological limits. Think about it. If a human diabetic has a blood sugar spike of just 2 to 10 times the normal level, the results are catastrophic. We are talking severe organ damage, kidney failure, even blindness. Yet the wood frog deliberately pushes its own blood sugar to 100 times normal. It's almost absurd to think about, right? A spike that would instantly destroy human organs is the exact, precise mechanism that saves the frog.
And this isn't just a wild theory. Professor Kenneth Story from Carleton University actually spent over 2 decades researching this exact phenomenon, and he notes that, incredibly, none of the severe damage human diabetics suffer from, even minor spikes, is seen in the frog. It's a biological system that just seamlessly handles extremes that would instantly break human physiology.
Section 2. The transparent ice fish, oxygen without hemoglobin.
This really brilliantly illustrates how extreme environments demand extreme biological engineering. But hey, the wood frog isn't the only example in our source material today. The crocodile icefish navigates completely different yet equally impossible constraints down in the freezing Antarctic. Get this, it has transparent blood. It has absolutely zero red blood cells. And astonishingly, it has zero hemoglobin, the molecule basically all vertebrates need to carry oxygen. It survives in one of the absolute harshest environments on the planet entirely without it.
So, the million-dollar question is, how on earth does it get oxygen? Well, Professor William Dietrich's research reveals what I can only call a masterclass in specialized biological engineering. Because the Antarctic waters are so highly oxygenated, the fish actually has scaleless skin. This lets it absorb oxygen directly from the water right into its body. And to circulate this oxygen without any hemoglobin, it relies on a disproportionately massive heart and extra-large blood vessels, pumping blood that is incredibly thin because it lacks those red blood cells.
Every single physical trait is meticulously customized for the extreme cold.
Section 3. The reperfusion dilemma.
Now, let's bring this back to our wood frog for a second, because waking up from being frozen introduces another massive hurdle. In human medicine, this is a critical problem known as the reperfusion dilemma. As Professor Matthew Anders explains, when a human suffers a stroke or a heart attack, the most severe tissue damage actually doesn't happen when the blood stops flowing. Counterintuitive, right? The massive damage actually occurs when the blood suddenly rushes back into those oxygen-starved tissues. So, when the wood frog thaws out and its heart restarts, it is essentially surviving a massive, systemic, full-body heart attack.
Exactly. What human medical science is still desperately trying to solve to save stroke and heart attack victims, the frog's biological system has already solved perfectly. And it executes this perfect, damage-free recovery every single spring, just as it has for millions of years. Honestly, the sheer technological superiority of this biological system, especially when you compare it to the absolute limits of modern human medicine, it's truly humbling.
Section 4. The factory analogy. Systems of survival.
So, how do we even begin to process this level of biological sophistication? The authors of our source material ask us to step back and look at this through the framework of intelligent engineering. Picture a highly advanced, human-engineered factory. When a critical danger is detected, let's say a fire breaks out or pressure builds up in a valve, automated safety protocols trigger instantly to prevent a catastrophic failure, right? Those protocols were deliberately coded by human engineers. Now contrast that with the wood frog. The exact second a dangerous ice crystal touches its skin, the liver automatically triggers a life-saving flood of glucose. The parallel here between intentional, engineered safety systems and the precise automation found in the frog's biology is really striking.
And this leads right into a fascinating question raised by the text. Think about it. How does the liver, an entirely unconscious organ, know exactly when to start this process? How does it calculate exactly how much glucose is required to create a 100x spike without just killing the frog on the spot, timing it absolutely perfectly before the freeze becomes fatal?
Does the frog itself possess the consciousness, the medical knowledge, or the sheer engineering foresight to design this complex process itself? Well, of course not. The frog is entirely unaware of the crazy biochemistry keeping it alive. It's merely the beneficiary of this incredibly advanced automated system, completely incapable of inventing it on its own.
Which brings us to the ultimate thesis of our source material. We see the icefish, with its highly customized cardiovascular system, and the frog, with its instantly reacting liver and total immunity to reperfusion injury. The source text asks a really profound question. Did these perfectly timed, totally interdependent, highly advanced safety systems just blindly assemble themselves by sheer chance? Or, as the authors argue, does this staggering level of integrated technology point to a master designer who foresaw the environmental dangers and deliberately installed these precise mechanisms to ensure survival?
To wrap things up, the source text anchors its whole argument in a really powerful thought, quoting a verse that speaks of being proportioned, balanced, and assembled. It argues that just as the frog's liver was perfectly proportioned for the winter and the icefish's blood was precisely balanced for the deep cold, these aren't just random accidents. They are masterful assemblies of life. So next time you look at a seemingly simple creature out in nature, ask yourself, what invisible, impossible engineering is quietly keeping it alive right in front of you? It's a lot to chew on. Thank you so much for exploring this fascinating explainer with me today.